Okay, in this section, we're going to talk about practical approaches to selection. Um, besides just wanting to know, who should I hire? We're looking at issues like who's likely to be successful in this position? Not just can I get a warm body in here, but like who's going to be good at this job? Um, Another thing that companies are always concerned about is it worth it? Is it cost effective to use this battery and implement this battery, to have it worked up, to vet it out, and then to actually implement it? Is it worth it? There are two major approaches to selection, the multiple cutoff strategy and the multiple regression method. So let's go ahead and talk about the two major approaches, keeping in mind their ability to determine who's going to be successful and whether it's really worth an employer's time to use these techniques. All right, with the multiple cutoff approach, this is what they call a non-compensatory method of employee selection, where you're not going to be compensating for different characteristics that they may or may not have. If they have passing scores, they advance. So that's why it's called the multiple cutoff, because the passing scores are the cutoff points. So if you exceed that cutoff, then you are considered a successful applicant, somebody who'd be worth hiring. A variation on the multiple cutoff approach is what's called the multiple hurdle. And this one is where you are going to administer your predictors in a predetermined order, usually starting with the least expensive. It could be the least expensive in time, like it's the quickest to administer, or it could be the least expensive, actually money-wise. But you start off with sort of the simplest screening technique. And those people who exceed the cutoff for that hurdle move on to the next predictor. And so that way you can sort of be putting the majority of your resources into screening ever more diligently those people who have the characteristics that at the minimum you need, and then a little bit above minimum they still have those characteristics, a little bit above that they have those characteristics, and then you move closer and closer to a person who's hireable. Both of these methods allow us to have sort of a predetermined cutoff point that the organization determines. Like the organization might have an initial cutoff of you need to have a bachelor's degree in social science or psychology psychology or other social science, it might say, in order to even make it past the first hurdle. Now that would be a really inexpensive criteria to set because it's going to be self-selecting. Most people won't even bother applying. If they do apply, it'll be really easy to weed out. And so that's a good criteria to set first. Okay, I only want people who have the educational criteria met. Then of those who have that criteria met, then we might go to the next level with a little bit more time-consuming technique. In the multiple hurdle, we'll do these sequentially. In the multiple cutoff, we might do them simultaneously. So you administer everything and then weed through everybody in the multiple cutoff. In the multiple hurdle, you do it sequentially from the least expensive to the more expensive predictors. All right, just for all of you statistics lovers in the class, I thought I'd go ahead and throw the multiple regression formula on the slide for you. Believe me, please trust me, I will never make you replicate this on a test. It's just kind of fun to look at. If you're having heart palpitations, take a few deep breaths. Because multiple regression is a statistical technique that's a lot like a correlation. The difference is you're factoring multiple variables in at one time rather than just two at a time. The idea with a multiple regression is that it's going to estimate how well a series of predictors, I put little circles around the x's because the x's are the predictors. So whatever the variables are, you've got x sub 1, maybe that's SAT score. X sub 2, maybe that's work history. X sub 3 might be typing speed. I don't know what job we're applying for here, but all these factors that we're going to be measuring, all these predictors we're going to be measuring are the X's. And they're going to hopefully forecast the criterion, which is the Y in this formula. So we want to know how well all these different X's predict the Y. Now this B sub O, in this particular notation, different people, I notice, write this multiple regression formula differently, which is one of the things that makes math so awesome. Can you please just use the same symbols? And then maybe we wouldn't freak out so hard. But anyway, the intercept is the B sub O, and that's where the line that we're going to be drawing from this formula intersects the y-axis. So if you imagine the x-axis and the y-axis on a graph, where the line crosses the y is going to be the B sub O value. And then the B values otherwise are going to be the slope. So how steep is this line going from, you got the 45-degree angle going up to the right, which would be a positive slope. You could have it 45-degree angle going down to the right. That would be a negative one. And then anything in between, right? All the way to flat, which is a 0. So it's just like a correlation. The difference is you have more than one predictor. So instead of x and y, and we're just trying to predict one from the other, now we have a bunch of x's, and they're all hopefully feeding into our prediction of y. Okay, that's just to sort of get your mind around it. Those of you who enjoyed stats and blew through it really easily, you're like, oh yeah, I know what we're talking about. Even though I didn't study multiple regression, at least this looks somewhat familiar. The idea in a multiple regression is that you're going to apply some kind of prediction scheme to the applicant data. I use the term scheme out of our textbook because I like that phrase. Scheme makes it sound like you've got something up your sleeve, but a scheme is just a strategy, step-by-step plan that you have for processing the information. So we're going to apply a prediction scheme to the data that have been provided by the applicant that we've requested, obviously, but they've provided information that we've asked for. Now we have to apply a scheme for interpreting it, and then we're going to rank order the applicants based on the predicted criterion scores. So using the multiple regression approach, we end up with a straight line where on, let's say, the x-axis, we have your score on this battery, the combined score that we got from your SATs, your work history, and your typing speed, as I mentioned in my earlier example. Those three predictors are going to be combined and weighted, and then we're going to have a line that's been drawn in the regression. The regression line will be drawn, and using that x-axis knowledge from this new incoming applicant, we can then go up to the line and then over to the left, the y-axis, and figure out what their criterion score most likely would be. Given what we know about their predictor, we're going to try their predictor scores. We're going to try and predict their performance on the criterion. This is when I wish I was at Khan Academy. I would have drawn that for you, but instead I made a bunch of gestures to myself, and I don't think you guys saw those. So, hopefully it makes at least reasonably good sense. The benefit of using this technique, because really seriously, it doesn't matter if we're doing this as a spatial task or what we're doing. The reason why we do this multiple regression approach would be that we can figure out using this technique what the best combination of tests is for maximizing the prediction of the criterion of job performance. So using multiple regression allows us to streamline our predictor collection, right? We can figure out which ones really matter and which ones we can quit asking for. Every criterion that we ask, every predictor that we ask for takes some amount of time to process, whether it's looking at it or typing information into the computer or administering an assessment center, or like all the way up to days worth of data collection. Everything takes some time. Everything takes some energy. So if we can streamline the approach and only include those predictors that really matter, then we're going to be better off in the long run. Things to consider with regard to the multiple regression approach is that we may want to set a cutoff score on whatever predictor we decide is important. We may want to set a cutoff score on the predicted criterion to exclude those whose performance is below the acceptable standard. So we may want to figure out, okay, so what is the minimum performance on this job that we would find acceptable? Okay, So that's going to be on our y-axis. That's going to be our criterion. Then we can go over to our regression line, drop down, and find out what x needs to be in order for us to say this is a person who's worth employing. They probably are going to meet our minimum criteria for performance. So you can kind of go start with the x's and then use it to predict the y, or you can take the y's of the people who already work for your company and then work backwards to figure out what the x's need to be in order to accurately predict a person who's going to have that level of y. So it's a nice, it can go both directions and help you to figure out what predictors you really need, and then maybe figure out what the cutoff should be on those predictors so that you can figure out who is likely to have at least the acceptable level of performance. So probably should have pushed that button earlier since that's what I was just saying. So we may want to establish these minimum cutoffs on each predictor to make sure that we're achieving our minimum performance standards on the Y criteria. All right, so let's go ahead and stop here, and then I'll come back, and in the next section we will talk about how useful the selection process can be.